So, in this lesson, we are going to learn a really important connection between the graph of an equation and the solutions to the equation. And I'm starting out on this first problem here with a really simple linear equation. Say I wanted to take this equation right here and solve it for x. Well, you guys all know that we would need to add the 6 over to the other side. We would get 3x equals positive 6. We would divide by 3. And the answer to this problem is x equals 2. Pretty straightforward question by this point in your guys' math careers. So I got my answer to the equation. That wasn't very hard. But what I want to do with this answer is show you actually how it relates to the graph of my original equation right here. What I'm going to do is pretend like this said y equals 3x minus 6. And I'm going to show you guys a little bit of a trick here. So what I would do to graph this is I would go down to negative 6 for my y-intercepts, and my slope is up 3 over 1. So I would go up 3 over 1, and I could go up 3 over 1 again, and I could just keep on getting dots. You guys all know how to graph a line. So this equation is going to look like what you see right here in red. The thing I want to draw your attention to with this graph is actually the x-intercepts, which happens right there on the picture. That x-intercept occurs at 2, 0. My x-intercept is 2, 0, and the answer to this equation, were you to actually solve it in the first place, is x equals 2. It turns out this always happens. The answers to the problem are the x-intercepts. If you're looking for like a reason why does that work, well, in my equation up here, I acted like there was a y, and I put a 0 in for y. When you plug a 0 in for y, you're finding an x-intercepts. So we're going to do another example, but that is a really big deal right here, the connection between the answers and the intercepts. So let's take a look at the second problem. Over here, this is a quadratic x squared, but whatever, I can just solve this thing by adding my 9 to the other side. I have x squared equals 9. And then what I would do is I would take the square root of both sides to cancel out the squared. I'm going to get x equals, and whenever you square root both sides, don't forget to do a plus or minus sign. The answer to this problem should be x equals plus or minus 3. So I have two answers to this equation. Now I'm going to go ahead and do the same thing as the last problem. I'm actually going to make a graph of x squared minus 9, pretending like this said y. Now this, I could go down to negative 9, and actually I'll go ahead and do that. If I'm all the way down here at negative 9, we know that there's a 1x squared, so I could go up 1 over 1 in both directions just for that 1 point either direction. But that unfortunately isn't going to help me see where my graph hits the x. I could continue plugging in numbers like a 2 and a 3 and stuff, or I can just turn to technology and graph my equation that way. That is actually what I'm going to do right here, showing you guys like with one of these graphing calculators. You would go to y equals up in the top left, and you can type in x squared minus 9. So if I do that and I go ahead and graph this equation, you're going to see a parabola, just like we've kind of talked about here. And if I look and just start using these arrow keys right here, I can get a little cursor. What you're going to end up seeing is that it hits, I can't get exactly on negative 3 just by moving my cursor, but it's going to hit at x equals negative 3. And if I keep on scrolling over to the other side, if you look right here, x equals 2.97, that's x equals positive 3 as well. So what's going to end up happening with that graph if I were to keep on plugging in points? Like if I wanted to make a little table or something? Well, this graph is going to hit at positive 3 and negative 3 on the x-axis. So this parabola looks something like what you see right here. So yet again, the answers to the problem are the x-intercepts. And that is such an important idea that I'm going to have you guys write that down with a big star by it. The x-intercepts are the answers, or are the solutions to the equation, as long as your equation is equal to 0. So that's a really big deal. If I have a graph, I can just look at where the graph hits the x, and boom, I have the answers to the original problem. Why is this such a big deal? Well, look at a problem like number 3 here. This is at x to the 3rd power. We have not learned how to solve a cubic equation. So what I'm actually going to do is just graph this thing, act like it said y equals, and I'm going to find the answers to this equation. So this time I'm going to go ahead and use a graphing website here instead of my calculator. This is Desmos, which is a really nice graphing software. I typed in my equation over here, and then if you look, I can see exactly where this graph is going to hit on the x-axis. So what I'll actually do with this right here is I'll just sketch a quick picture. It looks like my first answer is going to be at negative 1.384. So my picture for this third problem looks kind of, just doing a real quick sketch here, it's sort of like this. And if I look, my first answer is negative 1.384. That's one answer to this actual problem. If I keep it going and I look right here, this answer is negative 0.558. Well, that's another answer to this problem. And my last answer over here appears to be at x equals 1.942. So if I can find a graph for an equation, all I need to do is look at the x-intercepts, also called the roots. So x-intercepts are the same thing as roots, and it turns out they are critically important because they tell you the answers to a problem, even problems that we would not be able to solve by hand.